Hi, my name's Will, and I'm going to give you a step-by-step guide to the data analysis process. Let's go. In this video, we're going to go through the 5 key stages of the data analysis process. We're going to give you an overview and an introduction to each of these stages, as well as looking at some of the tools you'll use to undertake these stages. So let's dive into step 1, defining the question. The first step in your data analysis process, or any data analysis process, is to define your objective. In data analytics terms, this is called the problem statement. Defining your objective means coming up with a hypothesis and figuring out how exactly to test it. You can start by asking, what business problem am I trying to solve? Now, I know this might sound straightforward, but it can actually be trickier than it seems. For instance, your organization's senior management might pose a question such as, why are we losing customers? It's possible, though, that this doesn't get to the core of the problem. A data analyst's job is to understand the business and the business's goals. As a data analyst, you need to understand this in enough depth that they can frame the problem the right way. To give you a practical example, let's say you work for a fictional company. For example, we'll call it Top Notch Learning. This fictional company, Top Notch, creates custom training software for its clients. In this example, Top Notch is excellent at securing new clients. But unfortunately, Top Notch has much lower repeat business. As such, as a data analyst, your question might not be why are we losing customers, but which factors are negatively impacting the customer experience? Or even better yet, how can we boost customer retention whilst minimizing costs? Now you've identified the problem, you need to find which data is going to help you solve this issue. This is where your business acronym comes in again. For instance, perhaps you've noticed that the sales pipeline for new customers is very slick, but the production team is extremely inefficient. Knowing this, you could hypothesize that the sales process actually wins a lot of new clients. But the customer experience, well, it's kind of lacking. Could this be the reason that customers aren't coming back? What sources of data will help you answer this question? As a data analyst, considering all these things will help you define the question and help you solve the problem at hand. There's also a number of tools that can help you define your objective. Defining your objective is mostly about soft skills, so business knowledge and lateral thinking. But you'll also need to consider business metrics and key performance indicators, and these are called KPIs. Monthly reports can help you track problem points in the business. There are lots of tools out there on the market that can analyze this business data. Tools like Databox and Dasheroo. There's also free open source software like Grafana, Freeboard, and Dash Builder. These are fantastic for producing simple dashboards, both at the beginning and at the end of the data analysis process. So that was step 1, defining the objective. On to step 2. Step 2, collecting the data. Once you've established your objective, you'll need to create a strategy for collecting and aggregating the appropriate data. A key part of this is determining which data you need. This might be quantitative data or numeric data, e.g. sales figures or monthly reports, or qualitative, descriptive data, such as customer reviews. All of this data fits into one of 3 categories: first party, second party, and third party data. Let's explore each one briefly now. What is first party data? First party data is data that you or your company has directly collected from customers. It might, for example, come in the form of transactional tracking data, or information from your customer relationship management system, your CRM system. Whatever its source, first-party data is usually collected in a clear and structured way. Other sources of first-party data might include customer satisfaction surveys, focus groups, interviews, or direct observation. Let's talk about second-party data. To enrich your analysis, you might want to secure a secondary data source. Second-party data is simply the first-party data of other organizations. This might be available directly from the company or from a private marketplace. The main benefit of second-party data is that it's usually structured, and although it's less relevant than first-party data, it tends to be reliable. Examples of second-party data include website, app, or social media activity, like online purchase history or shipping data. So lastly, what is third-party data? Third-party data is data that has been collected and aggregated from numerous sources from a third party. Often, but not always, third-party data contains a lot of unstructured data or big data. Many organizations collect this big data to create industry reports or to conduct market research. The research and advisory firm Gartner is a good real-world example of an organization that collects big data and then sells it on to other companies. Open data repositories and government portals are also sources of third-party data. Let's take a moment to look at some of the tools that you can use to collect data. Once you've devised a data strategy, i.e. you've identified what data you need and how best to go about collecting it, there are many tools that you can use to help you. One thing you'll need, regardless of industry or area of expertise, is a data management platform, or DMP. A DMP is a piece of software which allows you to identify and aggregate data from numerous sources before then manipulating them, segmenting them, and so on. There are many DMPs available. Some well-known enterprise DMPs include Salesforce DMP, SAS, and the data integration platform Xplenty. If you want to play around, you can also try some open source platforms like Pimcore or DSwarm. On to step 3, cleaning the data. Once you've collected your data, the next step is to get it ready for analysis. This means cleaning or scrubbing it, and this is crucial to make sure that you're working with high quality data. Key data cleaning tasks include removing major errors, duplicates, or outliers, all of which are problems when you aggregate data from numerous sources. Removing unwanted data points, so extracting irrelevant observations that have no bearing on your intended analysis. Bringing structure to your data or general housekeeping, so for example fixing typos or layout issues, which will help you map or manipulate your data more easily. And finally, it helps filling in major gaps. As you're tidying up, you might notice that important data is missing. Once you've identified these gaps, you can go about filling them. A good data analyst will spend about 70% to 90% of their time cleaning data. This might sound excessive, but focusing on the wrong data or analyzing erroneous data will severely impact your results. It might even send you back to square one. So whatever you do, don't rush this step. Let's have a look at some of the tools that you can use to clean your data. Cleaning data manually, especially large data sets, can be incredibly daunting. But luckily, there are many tools available to streamline this process. Open source tools such as OpenRefine are excellent for basic data cleaning, as well as high-level exploration. However, free tools offer limited functionality for very large data sets. Now, I know this sounds like a data zoo, but Python libraries such as Pandas and some R packages are better suited to heavy data scrubbing. You will, of course, need to be savvy with the languages. Alternatively, enterprise tools are also available. For example, Data Ladder, which is one of the highest rated data matching tools in the industry. There are many more. Why don't you see which data cleaning tools you can find online? Share your free tools in the comments below. So that was step 3, cleaning the data. On to step 4, analyzing that data. Finally, once you've cleaned your data, now comes the fun bit, analyzing it. The type of data analysis you conduct largely depends on what your goal is, but there are many techniques available. Univariate or bivariate analysis, time series analysis, and regression analysis are just a few you might have heard of. More important than the different types though is how you apply them. This depends on what types of insights you're hoping to gain. Broadly speaking, all types of data analysis fit into the 4 following categories. Descriptive analysis, which is analysis which identifies what has already happened. This is a common first step that companies do before proceeding with deeper explorations. Diagnostic analysis, where the focus is on understanding why something has happened. It is literally the diagnosis of a problem, just as a doctor uses the symptoms to diagnose the patient's disease. Predictive analysis, which is where you identify future trends by the analysis of historical data. Predictive analysis is commonly used by businesses to forecast future growth. And lastly, prescriptive analysis, which allows you to make recommendations for the future. This is the final step in the analytics part of the process, but it's also the most complex. This is because it incorporates aspects of all the other analyses that we've described today. Step 5, sharing your results. You've finished carrying out your analyses, you have your insights. The final step of the data analysis process is to share these insights with the wider world, or at least with your organization's stakeholders. This is actually more complex than just sharing the raw results of your work. It involves interpreting the outcomes and presenting them in a manner which is digestible to everybody that's in the room. Since you'll also present your work to decision makers, it's very important that the insights that you share are 100% clear and also unambiguous. For this reason, data analysts usually use reports, dashboards, and interactive visualizations to support their findings. How you interpret and present results will often influence the direction of the business. Depending on what you share, your organization might decide to restructure, to launch a new product, or close an entire division. That's why it's very important to present all the evidence that you gathered and not to cherry-pick data. Ensuring that you cover everything in a clear and concise way will prove that your conclusions are scientifically sound and based on facts. On the flip side, it's important to highlight any gaps in the data or to flag any insights that might be open to interpretation. Remember that honest communication is an important part of the process. It will help the business, but it will also help you to excel at your job. There's a ton of tools for interpreting and sharing your findings. These tools are suited to different experience levels, but popular tools that require no coding skills include Google Charts, Tableau, Data Wrapper, and Infogram. If you're familiar with Python and R, there are also many data visualization libraries and packages available. For instance, check out the Python libraries Plotly, Seaborn, and Matplotlib. Whichever data visualization tools you use, make sure that you polish up your presentation skills too. Visualization is great, but communication is key. So hopefully now you have a better idea of the data analysis process. Career Foundry have an awesome data analytics short course, and you can sign up for free via the link in the description. Thanks for joining us today. I hope this video has been helpful. Here's another video I made about data analytics, which is just for you.